Hello everyone, I am Dr. Neelam Singh from ITS College of Pharmacy. So, in this lecture we will discuss the derived properties of the powder particle. In this micromeritics units we have already discussed all the importance of the micromeritics, what are the application of the micromeritics, what are the fundamental properties of the powder particles. So, continuation with our previous lecture. Now, in this lecture we are going to discuss the derived properties of the powder particles. So, properties of the powder, one is the fundamental property and second one is the derived property. Fundamental property is particle size and size distribution. So, for particle size distribution as well as the surface area is also a fundamental property. And the second one is the derived properties. Derived properties that are based on the fundamental properties, for example, density, porosity and packaging arrangement, bulkiness, flow property, these all are the derived properties of the powder. As you see in the picture in this image A and B, what is the difference between these two images? This is a somehow a symmetrical powder particle, this is also symmetrical powder, somehow symmetrical powder, but this particle is non-porous and these are the porous particle. Porous particle, that means the particles have a intraparticle space. Intraparticle space, that means the particles the space within the particle. So, this is the porous part, this is the porous, first one is the non-porous particle and second one is the porous particle. So, porosity of the particle will also play a role in the flow behavior of the powder particles. Now, first fundamental property, that is the density. What is the density? Density equal to mass upon volume. Mass is the fundamental property, volume is the fundamental property, and we can divide the mass from the volume, then we will get the density, and density is the derived property. So, density is the ratio of a mass of the powder and its volume. It is expressed in a term of a grams per cubic centimeter or gram per ml, because we can replace the centimeters cube with the ml. So, you can say a gram per ml or gram per cc. The symbol of density is the rho, the density is represented by rho. As you see in this picture, these are asymmetrical particles, because we know most of the pharmaceutical powder are asymmetric in shape, they are not a perfect sphere. So, these are the asymmetric powder particles, and the particles, the space within the particle is known as the intraparticle. Is intra, that means within, inter in between two. So, the particle, this space, this all spaces are known as intraparticle space, and this space is known as the interparticle space. So, how will you determine the bulk density? Simply you fill the weight amount of the powder in the measuring cylinder. Suppose that you have this measuring cylinder of 100 ml capacity, just fill 10 gram of a powder or a 5 gram of powder in this measuring cylinder. So, density equal to mass upon volume. Here, right now we are discussing about only the bulk density. So, bulk density, that is the undisturbed density, जिसमें कि आपने उसके powder के volume को बिल्कुल compact नहीं किया, there is a no tapping. So, density equal to mass upon volume. So, what will be the mass? 10. Suppose that volume occupied by 50 ml, then 10 divided by 50 equal to gram per cc will be its bulk density. So, either there are three types of density basically: bulk density, tapped density, true density and a granular density. सारी densities तो सारी same है, they all densities have a mass upon volume. तो difference क्या है यहाँ पर in among all these density? The difference in their volume, because you can't change the mass. आप मास, आप वेट नहीं, उसको नहीं चेंज कर सकते, तो क्या चेंज हो रहा है, सब में वॉल्यूम चेंज हो रहा है. तो इधर बल्क डेंसिटी और टैप डेंसिटी और ट्रू डेंसिटी और ग्रैनुलर डेंसिटी, द डिफरेंस बिटवीन अमंग ऑल दीज डेंसिटीज इज जस्ट बिकॉज ऑफ द डिफरेंस इन देयर वॉल्यूम. So, in case of the bulk density mass upon volume, but the volume, that is the bulk volume, include the actual particle volume plus interparticle space plus intraparticle space. For example, as this in this picture, in this image, if we are going to calculate the bulk density or a bulk for calculation of bulk density, first you have to know the bulk volume. Suppose that these particles are filled in the beaker. Now, this is 50 ml and the powder particle was 10 gram. So, how will you define dP, or sorry, it will be rho B, bulk density. What will be the value of rho B? Is 10 divided by 50. So, weight is 10 gram, volume is 50 ml, but this 50 ml volume include the volume of intraparticle space, volume of interparticle space, as well as the volume of this actual black colored solid particle. So, bulk volume contain the volume of interparticle space, volume of intraparticle space, as well as volume of actual particle. Actual particle volume to सारी densities में होगा, but in case of a bulk density, it will also include the inter plus intraparticle space. So, bulk density is denoted by rho B, and the bulk density is equal to density mass upon volume, and bulk volume, that volume of actual particle plus intraparticle plus interparticle space. So, this is denoted by the rho B, mass of the powder divided by bulk volume of the powder. And what is the bulk volume, which include everything, is it either it interparticle or intraparticle space as well as the actual particle. How will you determine the bulk density? Similarly, we have to fill the pre-weight amount of the powder sample in a beaker or a bulk density tester and just fill the volume, and without any compaction, you have to just make the level of that powder particle. Suppose that if you fill the powder in this beaker or the bulk density tester, so if the volume is the upper surface is like this, so what we have to do? We have to do just maintain it like this, nothing extra you have to do, and just determine the volume, and you know the amount divided by volume, then you will get the bulk density. See, 0 time of tap, that means no tapping, but just simply pour the 10 gram of powder or 20 gram of powder or 5 gram of a powder from here, and that what will be the volume? Just divide, for example, here 5 gram and it is a 50 ml. Because the measuring cylinder have a division, that is graduated cylinder, so you can measure the volume. So, 5 divided by 50 equal to 0.1 gram per cc will be the bulk density. Application of the bulk density, why we are going to determine the bulk density? For the selection of the mixing container, selection of the packaging container, choosing the size of the empty gelatin capsule, ये जहाँ भी हमें filling की requirement है, because filling is based on the volume. Whenever you are going to fill the capsules, or whenever you are going to fill the dye cavity during punching of the tablets, so this for before heading for these functions, we have to determine the density of the powder particles. Now, second one is the tap density. Tapped density is just like your bulk density. What is the difference between tapped and bulk? Just you have to tap that powder volume for at least 500 times. Rest procedure will be same as per the bulk density. So, bulk density is also known as the poured density. So, bulk density is also known as poured density. So, see in this is a 5 gram powder, okay. Here it is also a 5 gram powder. This is the bulk volume, that was the 50 ml. Without any tapping, we have just transferred the particles, the 10 gram or 5 gram of a powder in this container. So, 5 divided by 10 gram per cc will be your bulk density, rho B. Now, what will be the tap density? When we tap the same container minimum 500 times, So, what will happen if you tap that container 500 times, so automatically the powder particle will become compact. So, when it will be compact, then here the rho tapped equal to 5 divided by, so volume will be decreases or increases after tapping. Definitely after tapping volume will be decreases. Why it will be decreases? Because the जो भी air space base में था वो जब आप compact उसको करोगे, उसको compress करोगे तो that air space will be eliminated. So that become, suppose that 40 ml. So 5 divided by 40 gram per cc will be your tap density. So bulk density, that means without any tapping we just pour the sample in the measuring cylinder and just measure the volume and divide that volume from the weight or mass of the powder sample. But if we tap that measuring cylinder from its a constant height at least 500 times, so whatever the volume we will get, that volume if we divide from the weight of the powder, then you will get the tapped density. So that is the difference between bulk density and tapped density. Third one is the true density. True, that name itself denotes the true, that means the density of actual particle only. As you see in this picture, true density, that means bulk density, that means the density of volume of everything. Whatever it has been occupied, the volume of everything included in the bulk density, either intra or inter or actual, सब कुछ include हो रहा है bulk density में. But in case of the true density, कुछ भी include नहीं होगा. क्या include होगा? Only and only the volume of actual particle. यहाँ पर actual particle क्या है? What is the actual particle? That black solid particle is the actual particle. This is only your actual powder particle in case of the true density. So true density is equal to mass upon volume, and what will be the true volume? Volume of actual particle only, that means excluding inter and intra particle space. So that is known as your true density. So true density is equal to mass of the powder upon divided by volume of the actual powder. Practically, the true density is determined by the liquid displacement method by using the relative density or specific gravity bottle. This is the specific gravity bottle which you are using in your laboratory generally. This is the cap of this, like this. This is 25 ml approximate capacity of this relative. This is also known as the relative density bottle or a specific gravity bottle. This is used for the determination of the true density in the laboratory. Since you are using the simple measuring cylinder for the determination of bulk density and tap density, but for the determination of true density we have to go for the relative density bottle. थर्ड वन इज द ग्रैनुलर डेंसिटी. अब तीसरी ग्रैनुलर डेंसिटी क्या है? बल्क डेंसिटी, इसमें सब कुछ इंक्लूड है. डेंसिटी में आप वेरिएशन सिर्फ और सिर्फ में व्हाट यू हैव टू अंडरस्टैंड, दिस इज डिफरेंस बिटवीन द वॉल्यूम, बल्क वॉल्यूम, टैप्ड वॉल्यूम, ग्रैनुलर वॉल्यूम, ट्रू वॉल्यूम, बिकॉज द मास विल बी सेम इन अ ग्रैनुलर डेंसिटी. डेंसिटी इक्वल टू मास अपॉन वॉल्यूम. पर कौन सा वॉल्यूम? ग्रैनुलर वॉल्यूम. व्हाट इज द ग्रैनुलर वॉल्यूम? Granular volume includes the volume of actual particle plus intraparticle space, but it does not include the interparticle space. मतलब if this is asymmetric particles, so in a case of a granular density, we measure the particle like this. We also include the actual particle volume, this one, as well as the volume of this intraparticle space. So that is known as the granular volume. So granular density is equal to density upon granular volume. Granular volume is equal to volume of actual particle plus intraparticle space. So among all these densities, either a tapped, a bulk, a true or granular, there is only difference and in the volume. So what is the bulk volume, true volume and granular volume? Bulk volume, everything has been included, either interparticle space, the actual particle to include hoga hi hoga, because you are going to determine the density of that particle. So actual particle will be included in all these cases. But in the case of the bulk volume, actual particle के साथ साथ इंट्रा पार्टिकल स्पेस भी का वॉल्यूम भी देखना है आपको, इंटर पार्टिकल का भी देखना है. ट्रू वॉल्यूम में जाओगे कुछ नहीं देखना है, सिर्फ और सिर्फ एक्चुअल पार्टिकल का वॉल्यूम. ग्रैनुलर वॉल्यूम में जो पार्टिकल है, सिंस वी नो मोस्ट ऑफ द पार्टिकल आर एसिमेट्रिक इन शेप, सो पार्टिकल एक्चुअल पार्टिकल का वॉल्यूम देखना है और साथ ही साथ हमें इंट्रा पार्टिकल स्पेस का वॉल्यूम भी काउंट करना है, बट इट विल एक्सक्लूड द इंटर पार्टिकल स्पेस. सो दैट इज द डिफरेंस बिटवीन बल्क, ट्रू एंड ग्रैनुलर डेंसिटी. And the tap density is similar to bulk density after getting that volume, after getting 500 tapping of that same container. So this is all about the first derived property, that is the density, and here the 3 to 4 types of density you have studied. So the bulk density, tap density, granular density and true density. Bulk density सब कुछ included है. टैप डेंसिटी हाँ इंक्लूडेड है, कैसे, इसको 500 टाइम टैपिंग कर दिया तो थोड़ा कंप्रेस हो गया है. कंप्रेस होने की वजह से क्या हो गया, उसका वॉल्यूम थोड़ा सा कम हो गया, बट इट नॉट रीचेस टूवर्ड्स एक्चुअल ट्रू डेंसिटी. सो दिस इज नोन एज बल्क डेंसिटी और अपीयरेंट बल्क डेंसिटी और पोर डेंसिटी, ऑल आर सेम. दिस इज द टैप डेंसिटी and the granular density, density of this actual particle including this intraparticle space. True density, only and only density of the actual particle. So this is the difference between bulk, tapped, granular or true density. If the particle is perfectly non-porous, अगर पार्टिकल परफेक्टली नॉन पोरस होगा तो उस केस में ग्रैनुलर और ट्रू डेंसिटी सेम होगी. क्यों? क्योंकि उसमें इंट्रा पार्टिकल स्पेस तो होगा ही नहीं. इफ इट इज अ परफेक्टली नॉन पोरस पार्टिकल, सिमेट्रिकल परफेक्टली नॉन पोरस पार्टिकल. नाउ नेक्स्ट वन इज द पोरोसिटी. What is porosity? Porosity, that means the void space. Void space, that means the interparticle space. Porosity or void denoted by the epsilon. Voids, the interparticle space is known as the void. Suppose that we have filled a 1 gram or a 10 gram of powder in a container. So that container, that powder will occupy the volume of actual particle as well as the interparticle space as well as the intraparticle space. That interparticle space is also known as the air space or a void volume or an interparticle space. Suppose that here in both container you have filled the powder, but as you see in the can see in this picture, here is the more porosity and here is the low porosity. Why here low porosity, here more porosity, high porosity? Because high void volume, well this volume is more. See, this is the void volume or porosity. Here the porosity is less, because the particle packing of the this packaging of these particles are more compact. So this is the high porosity, this is the low porosity. So when we purge the air, just as we have studied in our previous lecture in an air permeability method for determination of the surface area, when we purge the air in this sample as well as in this sample, which sample will possess more resistance in flow, this or this? Definitely this. जिसकी पोरोसिटी कम है उसमें रेजिस्टेंस ज़्यादा है. कहाँ से एयर निकल के उधर साइड जाएगी? एयर को कहीं मूव करने के लिए क्या चाहिए? पाथ चाहिए, फ्री स्पेस चाहिए. तो जब पोरोसिटी कम होगी तो उस केस में रेजिस्टेंस किसी चीज़ को फ्लो होने में, मूव करने में कम होगा. अगर कम पोरोसिटी होगी तो मूव करने में रेजिस्टेंस ज़्यादा होगा, और अगर हाई पोरोसिटी होगी तो उसके थ्रू किसी चीज़ को पास करने में आइदर फ्लूइड और लिक्विड देयर विल बी अ लो रेजिस्टेंस. Similarly, if you are going from the crowded road, you will face a much more hurdle. But when you are going to an empty road, so what will you can easily move. Similar condition here. If you are low porosity, there will be low hindrance. there is a low porosity, that means there will be high hindrance, and if there is a high porosity there will be a low hindrance. Now, as it is denoted by the epsilon, epsilon equal to bulk volume minus true volume upon bulk volume. How will you determine the porosity? Porosity is determined by the bulk volume minus true volume upon bulk volume. And what is the true volume? What is the bulk volume? That is the volume included inter and intraparticle space. If the powder is non-porous, that there is a no interparticle space, in such cases bulk volume of the powder is equivalent to towards their true volume. Total porosity, that means the epsilon T. Total porosity is represented by epsilon T. Total porosity of the powder is defined as the ratio of the void volume to the bulk volume of the packaging. This will give your void volume divided by bulk volume, and if it is multiplied by 10, then it become a epsilon percentage. So, total porosity of the powder is defined in the ratio of the void volume divided by bulk volume multiplied by 100, percentage porosity. So, porosity is frequently expressed in the term of a percentage total porosity. Porosity just represent the perforation. जितना ज़्यादा porous होगा material, उतना ही उसके through किसी भी चीज़ को pass होने में, either a liquid or a gases, it will be easily passed out. The formula for the calculation of the epsilon T, the percentage epsilon T, that is why we have just multiplied everywhere by 100. Percentage epsilon T equal to bulk volume minus true volume divided by bulk volume. If we can rewrite this equation in the term of their density, also, then epsilon T equal to 1 minus m divided by rho T divided by m minus rho B. So, just inverse, because the density and volume are inversely related, for density equal to mass upon volume. So, there is an inverse relation between density and volume. So, in the term of the volume, this equation is this. Whenever you are going to write this equation in the term of density, it will become opposite, this inverted. And this is the formula for the calculation in term of the volume, and this is the formula for calculation of epsilon T, that is the total percentage porosity in term of the density. What is the application of porosity? Why we are studying porosity? Is there any use of this porosity in a pharmaceutical dosage form? So, porosity यानी कि void space, void volume, that porosity value provides information about the hardness, hardness, disintegration, tablet porosity, and thereby the dissolution as well as the release of drug can be anticipated. For example, if the porosity will be more, then the hardness of the particle will be less or more. If the particle, suppose that this is the tablet, one tablet, this is the second tablet. Epsilon, this is epsilon. This is tablet number 1, this is tablet number 2. Tablet number 1 have a less porosity, and this tablet number 2, tablet number 1 have a more porosity, and tablet number 2 have a less porosity. The tablet which have a high porosity will disintegrate more easily and will dissolve more easily as compared to the tablet having the low porosity. So, porosity value of the tablet will anticipate the hardness of the drug, ultimately the dissolution, ultimately its disintegration, dissolution, and finally the absorption of the drug. Next is packaging arrangement. If it is assumed that the powder particle in a given samples are of uniform size and spherical, then the packaging arrangement is like this. When the particles are uniform in size and are spherical, but actually in practically pharmaceutical powders are not in uniform size, and they are not symmetrical also, even they are asymmetric in shape. So, suppose that if the particles are spherical and they have a symmetrical shape, so how we can pack them? We can pack in the two ways. One is the closest packaging without any void space, कम से कम जगह में ऑक्यूपाई हो जाएंगे. सेकेंड वन इज द लूजेस्ट पैकिंग, मैक्सिमम जितना फैल के अपना ऑक्यूपाई कर सकते हैं उतना करेंगे. तो जब मैक्सिमम एरिया आप सरफेस को कवर करेंगे तो उस समय क्या होगा, उसमें वॉइड स्पेस होगा, दैट इज नोन एज द वॉइड स्पेस. And in case of the closest or rhomboidal packaging there will be a no void space, the compact packaging, and this is the loosest packaging. So, when the packaging will be compact, there will be minimum porosity which is a 26%, and when this packaging will be loosest, बहुत आराम से पैक किया हुआ है, कोई there is not requirement for regarding the container, it is just freely packed. So, in this case that the volume, there will be a high void volume, it will be a 48%. The void volume is directly related to the porosity. जितना ज़्यादा void volume होगा उतनी ज़्यादा उसकी porosity होगी, उतना ही porous होगा वो material. So, practically powder sample do not have a uniform size and spherical nature. So, ना तो practically powder particles symmetrical in nature होते हैं और ना ही एक uniform size के होते हैं. तो इसलिए जो उनकी packaging arrangement में जो porosity है, that porosity is not about 26% or a 48%, it is actually 30 to in a range 30 to 50% is the total porosity of the asymmetrical particles. If the smaller particles are of such size that they occupy the interface or interspace between larger particles, then the total porosity may be even less than 26%. If there is a mixture of powder particles, this means the polydispersed particles. So, what will happen when we pack this polydispersed particle in a beaker, in any container like this? That is the larger particle, and some are smaller particles. So, a smaller particle, because of the polydispersed in nature, all particles are not exactly of the same size, they are in the size range. So, smaller particle will occupy this space or void space. In that case, the total porosity or even of asymmetric particle will be less than even 26%. Second, powder contains floccules, then total porosity will increase, and it increases beyond even 48%. Powder contains flocks. Suppose that यही particles आपस में एक दूसरे के साथ आके flocks बना लें. This is known as the individual particles. ठीक? When we come closer, then come closer like this. As in case of the dispersion system and emulsion and suspension, they come closer and make a flocks. And whenever they make a flock, ultimately what will they become a bigger in size, and the size whenever the size of the particle will increase, then the porosity or the void space will also increase. So, that will be even more than 48%. The porosity of the powder decreased by compression of the powder as low as 2%. So, the space occupied for the storage of the powder will depend on the total porosity. Thank you. This is all about for the today's derived properties of the powder samples. In the next lecture, we will study the packaging arrangement as well as the bulkiness of the powder particles.